Frequency Distributions and Histograms. AP Statistics, Period 2. Well, what are frequency distributions anyways? A frequency distribution is a mathematical function showing the number of instances in which a variable takes each of its possible values. Here's an example of a frequency distribution. What we did was in one column we put the score, and the other column we put the frequency. We got the frequency by counting the number of times that score appeared in our dataset. So what are histograms? A histogram is a diagram consisting of rectangles whose area is proportional to the frequency of a variable and whose width is equal to the class interval. So here's an example of a histogram. Remember, a histogram is a graph, so you must label both your axes, have a scale, and have a title. On the x-axis or the horizontal axis, you put the variable you're observing. In this case, it was the height in feet of black cherry trees. Make sure you put the unit next to the height. On the y-axis, you can either put the frequency or the relative frequency. In this case, we put the frequency. Always remember that in a histogram, the bars must be touching. In a histogram, the x-axis is going to be divided into intervals. Look at the first rectangle in this histogram. The left-hand side starts at 60 and the right-hand side ends at 65. This shows that the data in between that interval is between 60 and 65. This continues for every interval in the histogram. How do frequency distributions and histograms relate? Frequency distributions and histograms are displays that are useful for summarizing even a large data set in a compact fashion. So now, what is relative frequency? Relative frequency is the ratio of the number of observations in a statistical category to the total number of observations. Here's the formula. And you must memorize it. It's really helpful. Relative frequency is equal to the frequency divided by the total number of observations. Another formula for relative frequency is the rectangle height multiplied by the class width. The sum of all the rectangles, or the relative frequencies, is 1. Now we're going to look at histograms for discrete numerical data. So when would you use this kind of histogram? Use it for discrete numerical data and for either large or small data sets. So, how do you make one? First, you have to draw and label your x and y axes. Then you set the scale for both and make sure you have the correct units. If you're going to use the relative frequency on your y-axis, you need to make sure the highest unit value on your scale is 1. Remember, the relative frequency is the sum of all the frequencies together, which totals to 1. Mark the variable on the x-axis either individually or in intervals. Remember to mark the y-axis with either frequency or relative frequency. Now at each value, draw a rectangle that is centered at that value. Now that we have graphed our data, what are we looking for? Look for the most popular value, which is indicated by the tallest rectangle. Next, look at the spread to observe the variation. The larger the spread, the larger the variation. Observe the general shape of the graph and the location and number of peaks. If you see any gaps or outliers, ask yourself why, and answer that question by looking at the context of the problem. Next, we're going to look at histograms for numerical data. When to use? Use for continuous numerical data or for large or small data set. How to construct? Mark the boundaries of class intervals on the horizontal axis. The vertical axis should be labeled with either frequency or relative frequency. Draw a rectangle for each class directly above the corresponding interval. So what are we looking for? Look for the same components you look for in discrete numerical data histograms. But what about the intervals? There is a formula to determine the number of intervals. The total number of intervals is the square root of the number of observations. Next are histograms for continuous data with unequal class widths. When class widths are unequal, Do not use frequencies or relative frequencies on the y-axis. Instead, use the density. Density equals relative frequency divided by class width. With density, the vertical axis is called the density scale. Each rectangle's height should be drawn to its calculated density. Something to note is that the density scale of a histogram ensures that rectangle areas are proportional to the relative frequency. You could use the density scale when class widths are equal. This graph will look the same as your relative frequency graph with a different vertical axis. But why is that? This is because since the widths are the same, the denominators will be the same. The last thing we need to do is dissect the histogram. Histograms have an upper tail and a lower tail. Histograms come in different shapes. There are uniform, bimodal, multimodal, symmetric, non-symmetric, positive skew, negative skew, normal-tailed, heavy-tailed, and light-tailed.